Number bases. In the previous chapters, we looked at binary numbers, and binary numbers, we know binary numbers to be base 2. Now in this chapter, we're going to look at other bases beyond base 2, from base 3, 4, 5, 6, 7, 8, and 9. Now you already know that the numbers we use daily, as we go to the markets, as we count our multiplication table, everything is in base 10. Now we're going to learn to express numbers in other bases apart from base 10. Now the important things you should know is that when you're counting in any other base, for example, let me use base 10 that we're used to. Base 10. That will count 1, 2, 3, 4, 5, 6, 7, 8, 9. Then there is nothing actually like 10. When we get to 9, we'll go back to 1 and instead add 0 to the end. Then we'll now have 1, 1. Then we increase this 1, 2, 1, 3 down to 1, 9. And once we get to 9 again, this 9 becomes 0. And this 1 increases to 2. So we'll count again till we get to 9. 29. On getting to 9, this comes back to 0, and this increases to 3. Okay? So that's the concept of base 10. Now when we're counting in other bases, the same applies. For example, base 5. Base 5 means we'll count 1, 2, 3, 4. There's nothing actually like 5. We'll now have 1, 0. Then we'll now have 1, 1, 1, 2, 1, 3, 1, 4. We'll have 1, 5. On getting to 5, we'll now increase this to 2. So that's how we'll count. Like that, forward. So now we're going to learn to convert numbers from base 10 down to base, other bases. Okay, let's start with base 2. Now the first example says convert 25 to base 2. Okay, when you just say a number like this, 25, it automatically means that it's base 10. So what we're going to do is, like we're solving our LCM, we'll divide by 2 and write the remainder. So 25 divided by 2 will give us 12, remainder 1. Then 2 divided by 12 will give us 6, remainder 0. 2 divided by 6, 2 into 6 will give us 3, remainder 0. 2 into 3 will give us 1, remainder 1. So we've now gotten to 1. So what we'll do is we'll count up this way. So our answer becomes 1, 1, 0, 0, 1, base 2. Okay? So this is our answer. Let's look at another example. Base 8. Convert 692, which is in denary. Denary should remind you of something when we talked about decagon, octagon, nonagon. December stands for 10. So 692 is in denary, which is base 10. Convert it to base 8, which is octal. Okay, so as usual, like we did for the other one, divide by 8, 692. So 6 into 692, 6 into 69 will give us 8 here, 64. Then 5 will have another we'll have 6, which is 48, remainder 4. Okay, so 18 to 86, we'll have 10, remainder 6. 8 again, we'll have 1, remainder 2. So as usual, we'll count this way, and our answer now will be 1, 6, 1, 2, 6, 4, base 8. Okay, So let's try base 7. I hope you get the idea. It's just as simple as it is 69 to base 7. We'll put it this way, 69. So we'll have 9, which is 63, remainder 6. Then 7 dividing again. We'll have 1, remainder 2. Okay, so we'll count up. Our answer now becomes 126 base 7. So it's just as easy as it feels. Okay. Now, what if you are asked to convert from one base, which is not base 10, to another base, which is not also base 10? Okay. Before we do that, let's see how to convert back from another base to base 10. For example, we have 1 0 1 1 1 0 2 convert to base 10. Okay, so since we're working with base 2, what I'm now going to do is to count from here, from this end. We'll count 0 1 2 3 4 5. Okay, I haven't counted that. We'll now do 1 times 2 raised to the power 5. Okay, then plus 0 times 2 raised to the power 4, plus 1 times 2 raised to the power 3, plus 1 times 2 raised to the power 2, then plus 1 times 2 raised to the power 1, and plus 0 times 2 raised to the power 0. So we've come back to indices. 2 raised to the power 5 is 32, plus 0 plus 8 plus 4 plus 2 plus 0. 32 plus 8 will give us 40 plus 6. So answer equals 46. So to confirm that we're correct, we'll convert 46 back to base 2. This you can do behind your answer sheets if you're in the exam hall. So 2 into 46 will give us 23, remainder 0. 2 again will give us 11, remainder 1. 2 again will give us 5, remainder 1. 2 again will give us 2, remainder 1. Then 2 you have 1, remainder 0. So if we count up, this will have 1 0 1 1 1 0, which is what we started with. So we're correct. Okay, so let's try converting another number to base 10. So we have 1264 in base 8, convert to denary. Okay, so to convert to denary, we have as usual 1 0 2 3. We now have 1 times 8 raised to the power 3 plus 2 times 8 raised to the power 2 plus 1 times 8 raised to the power 1. Sorry, 6 times 8 raised to the power 1, then plus 4 times 8 raised to the power 0. So 8 raised to the power 3 will give us 64 times 8. 2, 3, 48, 512 will give us 512. Then plus 64 times 2 will give us 128. Then plus 48, and anything raised to the power 0 is 1, plus 4. So we'll have 512 plus 128. That will give us 640. Then plus 48 will give us 688. And plus 4, that will give us 692 to base 10. So that is our answer. So anytime you're told to convert from another base, let's say 45 base 7 to base 3. The first thing to do is to convert 45 base 7 down to base 10. So when you get in base 10, you now convert base 10 down to base 3. Okay, so it's still the same process. We're not going to repeat it. Now let's look at another problem: addition and subtraction of numbers in bases other than 10. Okay, So the principle is still the same thing as when you're working with base 10. Let's say we have 1 0 1 1 base 2 plus 1 1 1 1 base 2. So arrange it this way. Put our addition sign. 1 plus 1 will give us 2. But instead of writing 2, write 0, carry 1. So 1 plus 1 plus 1 will give us 3. We can't write 3. So what are we going to write? We'll write 1, carry 1. Okay, because the 3 minus 2 will give us 1. So write 1 and carry 1. So 1 plus 1 will give us 2. 2 minus 2 is 0. So write 0, carry 1. So 1 plus 1 plus 1 is 3. We'll write 1, carry 1. So this is our final answer. 1 0 1 0 1 1 0 1 base 2. Okay, let's try another one in another base. 145 base 7 plus 36 base 7 plus 504 all in base 7. So 5 plus 6 will give us 11 plus 4 is 15. So what we're going to do is 15, we'll write 15, if we divide it by 7, we'll have 2 remainder 1. So we'll write 1 and carry 2, which is this 2 we'll have here. So the 2, we'll place the 2 here. 2 plus 4 is 6. 6 plus 3 is 9. 9 plus 0 is 9. So the difference is 2. We write 2 and carry 1. 1 plus, we put the 1 here. 1 plus 1 is 2. 2 plus 5 is 7. So 7 minus 7 is 0. Carry 1. So this is our final answer. 1021 base 7. Now what you need to understand is what I did here. Normally what you do is to subtract the final, what you get here, this plus this plus this, subtract from 7 and know what to write and what to carry. But this was way too high. Let's say we had done 15 minus 7, we would have gotten 8, which is carry 1. 8 minus 7 again will give us 1, carry 1. So that the 1 plus 1 is 2, carry 1. So that's why I simply did 15 divided by 7, which is 2 remainder 1. So wrote 1 and carry 2. Okay, so that's our final answer. Now the same thing applies to subtraction. Let's take an example in subtraction to understand the points very well. Okay, the first example says 64 base 8 minus 46 base 8. So we'll arrange it 64, 46. 4 minus 6, it won't go. So we'll take 1 from here and add to this. And when you add, the one you borrow will be 8. Okay, because we're working with base 8. 8 plus 4 is 12. 12 minus 6 will give you 6. So we'll have 5 here left. 5 minus 4 will give you 1. So our answer is 16. 16 base 8. Okay, let's take another example. We have 61 base 8 minus 46 base 8. So 61, 46. 1 minus 6, it won't go. Borrow 1 from here. This remains 5. And the 1 is 8. Then 8 plus this one will give us 9. 9 minus 6 is 3. And 5 minus 4 is 1. So we'll have the answer as 13 base 8. Okay? So it's just as simple as it sounds. Now at this point, I want you to click on start quiz and answer all the questions